Hello everyone. I hope that all of you are doing great. So welcome back to the channel. We are going to continue with our series. In the previous series, we have completed a chapter of biology. Not completed, but we have completed a part of it. We started with the cell, chapter cell and its organelles. We are going to continue that further in another video. So what I'm going to do for you guys is that I'm going to create a playlist, okay? And this playlist is going to have all the, like, it would be subject wise, and all of the videos, like from the biology section would be compiled, then from the physics section would be compiled, etc. Okay, so I'll do this thing. So we're going to continue with this series today, and today I'm going to start a topic of chemistry. Okay, that is going to be matter. Okay, so if you go through the syllabus of KVS NVS, so you can see that this topic is very much important. And for all the people who have joined this video, I've already created another video of biology. You can check that out on the channel. And this is going to be the second video on this channel relating to KVS NVS Tier 2 exam. And these series are specific for TGT science. Okay. So now without any further ado, let's start. So the today's topic is going to be matter. So when we talk about matter, so matter is, if I define it like roughly, so it is anything that occupies space, anything that occupies a space and also has a mass. Okay, so this is the general definition. I'm not going to write everything on the screen. Okay, what I'm dictating, you guys can write that out. Okay, on the screen, it is only going to be the important points that would be written. Okay, so first of all, before going into this chapter and before going into the details, today's video is going to be very, very important and very, very, useful for you guys, because today we are going to cover all the confusing topics relating to, different kinds of laws of combination. Okay, so I'm going to be doing laws of combination in this particular video. That is going to be the main central topic. But for that, we need to understand what is matters. Okay, so I'm just giving you a quick study of matter. Okay, so if I'm going to broadly classify matter, so like this is matter, I'm going to write it like this. You can also create this kind of a flow chart in your exam. Okay, so anything that occupies space and has mass, okay, that is called as matter. So I basically, first broad categorization would be on the basis of its physical characteristics and on the basis of its chemical characteristics. Okay, so this is the first characterization. On the basis of physical, if I'm going to move forward, okay, so I'm going to change colors so that we are going to be able to see it more clearly. So this one, first one is going to be solid. Okay, second one is going to be liquid. Third one is going to be gases, and here I'm just doing the broad one. Otherwise, we have Bose-Einstein condensate as well. Okay, and we have, okay, so we have Bose-Einstein condensate, Bose-Einstein condensate as well. I'm just mentioning it here. That is the fourth stage, and fifth stage is plasma. All both of these stages are also needed to be studied, but I'm going to cover it in the next video. Okay, so yeah, solid, liquid, and gas. Okay, this is the major one. Then we go when we go into the section of chemicals, so we have next broad classification into mixtures and pure substances. Okay, so there are pure substances and there are mixtures. Okay, now when I go further, in mixtures, in mixtures, I have homogeneous mixture and heterogeneous mixture. Okay, homogeneous and heterogeneous. And in the pure substances, we have, I'm going to do it like this, that is going to be elements and compound. Okay, so the this one is the rough whole classification of whole matter. Okay, whatever the matter is, we have classified each one of it. And now we are going to write about, now we are going to write about its, what is physical, what is chemical. We are going to understand everything. Okay, so when I talk about physical and chemicals, of course, on the basis of how it looks, and this is on the basis of its chemical reactivities and characteristics. Okay, if I talk about solid, so of course it has a definite shape. We all know this. Okay, so shape is going to be definite and volume is also going to be definite for solid. Okay, like if I have to draw, how would a solid look like? Okay, so a box of solid would look something like this. Okay, they are going to be very close. The particles are going to be very closely attached to each other. There are not going to be any kind of spaces in between the particles. Okay, so this is what a solid would look like. Fine. When I talk about when I talk about liquid, so shape is the shape is not going to be definite, but volume is going to be definite. Okay, and in gas, both shape and volume are not going to be definite. Okay, now when I come to the mixtures part, so in the mixture, of course, there are more than two different kinds of particles. So there is a variable composition that you are going to observe in mixtures, and in pure substance, there is going to be a fixed composition. Okay, same kind of atoms and molecules will be present throughout the mixture, sorry, throughout the pure substance. Okay, so if I talk about homogeneous, so homogeneous, of course, you know that the one which have a uniform composition. Okay, the one which has a uniform composition. Heterogeneous is the one which does not have a uniform composition, or we call as non-uniform composition. Okay, now coming to the elements. If I talk about elements, so element is the one which is a part of pure. Okay, so the composition is of course going to be fixed, but we know like in the element, it is like in the elemental stage. If we say that something is in the elemental stage, what do we mean? It means that it is in the simplest state. So elements are in the simplest stage and cannot be broken down further, cannot be broken further. Okay, that means broken means cannot be further broken down into the smaller or simpler components. Okay, whereas when we talk about the compounds, so they can be decomposed into smaller, simpler substances. Okay, so this was the whole flow chart that I hope that all of you understood each one of it. Now I'm going to move onto a next topic. So what the topic is going to be. So as I told you, we are going to be studying about the laws of chemical composition. So what does this topic mean? So as we studied that properties of matter are also chemical in nature. In the chemical composition, we are going to study how different kind of atoms and molecules they interact with each other and how do they form different kinds of compositions. Okay, so if I talk about first one, what is first one going to be? The first one is going to be the law of conservation of mass. Law of conservation of mass. So this is the first one. Okay, law of conservation of mass. Okay, so law of conservation of mass, it is just going to imply that mass can neither be created nor destroyed. First, neither created nor destroyed. That means this would imply that second, what it can do, it can change its it can change its like state, okay, and it can basically convert, okay. So it is neither created nor destroyed, okay. If I want to give you an example, so the best example is of mercuric oxide. So whenever we talk about mercuric oxide, so it has mercury plus oxide form of mercury. So if I've taken like 100 grams of mercuric oxide, and since mass is neither created nor destroyed, so if I'm going to heat this up, so it should be broken down into the simpler units of mercury and oxygen. Okay, and this mercury, or rather I write here oxide. Okay, so this mercury is going to be 92.6 grams, and the remaining, that is going to be 7.4 grams, which is going to be oxygen. So if you combine both of them, you'll again get 100. That means that the mass has been same. Okay, though it is converted into simpler substances, but the mass is not destroyed. Okay, it is the same. So this was first given by the chemist. This concept was first, rather this whole experiment on mercuric oxide was done by the chemist who is called as Levi-Oster. He was a French chemist, okay, and he first of all gave the idea about this law of conservation of mass. Okay, this one was the first one. Now let us move to the second law. What is the second law? So second law is the law of constant or definite proportions. Law of constant or definite proportions. As the name suggests, as the name suggests, we can say that law of constant or definite proportions, it is going to state that the reacting elements, they would always combine to form a compound in a simple whole proportion. Okay, what does this mean, Dekho? Simply, what does this mean? If there are certain elements, okay, and they react, of course, the elements are going to react with each other to form a compound, okay, and this compound would be formed in a way that the compounds are going to be combining together in the simple whole ratios. Compounds are going to combine with each other in the simple whole ratios. Okay, so also it like if I give you a solid definition, so it is a chemical compound that is formed which contains exactly same proportion of elements by mass. Like for example, I'll just show this to you with an example. You'll be able to gather it much more clearly. So if I take the example of cupric carbonate, okay. So what is cupric carbonate? Okay, it has three components. Like if I break it down, okay, it has same it has like copper, it has what, carbon, and it also have oxygen. Okay, these are the three components. So if I take definite proportion means if I take cupric carbonate from the natural source, or I take cupric carbonate from the synthetic source. In both the cases, the proportion of these elements, these participating elements, is going to be same. In same proportion they are going to combine, and the proportion is going to be simple whole number. Okay, so it states that a chemical compound which contains exactly the same proportion of elements by mass irrespective of the source. Okay, so like there was a whole experiment that was conducted on this, and after the experiment it was concluded that all of these compounds were in same proportion, in exact same amount in both the cases, in the natural as well as in the synthetic case. Okay, so this law. I hope that this law is clear to you. You can revisit the video if you have any kind of doubt, and still, if you are unable to grasp anything, you can, of course, ask in the comment section. Okay. Now, let us come to the third law. What is the third law? The third law states the law of multiple proportions. The law of multiple proportions. Fine. So we have seen the law of definite proportions. Okay, but now we are going to see law of multiple proportion, which is not same as the definite proportion. Okay, so it is completely different. So when I talk about the law of multiple proportion, I need to, yeah. Okay, so law of multiple proportion. When two elements, okay, when the two elements they combine with each other to form a compound, okay, a compound, more than two elements also combine, okay, then one of the elements that combine with the fixed mass of the other element in the simple whole ratio. I'm going to write this down, okay. Two elements, and I'm just going to write in a flowchart form. They combine together. Of course, they are going to form a compound. Then all the elements that have combined, the elements that have combined they've combined with the fixed mass of other element. What does it mean? It has combined with the fixed mass of the other element. I'm going to show you by an example and you'll be able to understand it clearly, very clearly. Okay. For example, I have CO and I have CO2. So this is carbon monoxide, this is carbon dioxide. Okay. Now, when I see carbon here, so in this carbon monoxide, there is 12 parts of carbon. Okay, there is 12 parts of carbon, and in carbon dioxide as well there is 12 parts of carbon. Okay, now you have to be very, please be very attentive, because this particular one is a bit confusing. It can be a bit confusing sometimes, but we are going to look at this example and everything would be clear. Okay, so when I say 12 parts of carbon in carbon monoxide as well as 12 parts of carbon in carbon dioxide. Now we have oxygen. Okay, here it is O and here it is O2. So here it is going to combine with 16 parts of O, and here it is going to combine, since it is an O2, so it is 16 parts of O2. Not 16, sorry, 32 parts of O2. Sorry, 32 parts of O2. Okay, or O. So there are 32 parts and here it is 16 parts. So according to my definition, when two elements they combine, two elements have combined, they form a compound. Now these elements, now here what are the two elements? Here the two elements are carbon and oxygen. Okay, and they have combined to form two different kinds of compounds. Okay, so there is a fixed mass of one of the element that combines with the other one. Okay, so the carbon is going to be having a fixed mass in both CO2 and in CO. Okay, and also it is going to be in simple whole ratios. You have to add this as well. Now what does this mean? Now if you see here, like there are 12 parts and there are 12 parts. Okay, and here it is 16 parts and it is 32 parts. So if I see the ratio of both the compounds this way, the other one, if we are going to see the ratio of that, so we are going to see it is in the ratio 1:2. So it is the simple whole number ratio, okay? Simple whole ratio. I hope that this was very clear to you, okay? I'm going to explain it to you once more because it was a bit, it was a bit different, okay? So if I have two cases, we have carbon monoxide and we have carbon dioxide, okay? If I'm going to see here the parts of elements that are combining, so carbon and oxygen, okay? I'm going to create a table like this. So carbon here is 12 parts and here also it is 12 parts, okay? But oxygen here is going to be 16 parts and here it is going to be 32 parts. Okay, so here I've seen that in both the compounds, okay, there are carbon element and oxygen element, okay, and there is a fixed mass of one of the element and it combines with the other element which has simple hole ratio, okay. The other element is not fixed, but it is a simple hole ratio, okay. And how do we know that this is a simple hole ratio? We can just prove it here as only like this is 16 parts, okay, and this is 32 parts. So if I'm going to simplify it, we are going to get 1:2, which is a 1:2, which is a simple whole ratio. Okay, so I hope that this was very much clear to you, all of you. Okay, now let us move on to the next one. I hope that the law of multiple proportions was clear. Now we have our, I don't know the number, which I think it must be for second, third, yeah, fourth law. So this is the fourth law. The fourth law is Gay-Lussac's law. Gay-Lussac's law of gaseous volume. पूरा ही लिख लो. Of gaseous volume. So when I talk about this law, so this law is also very simple. It just suggests that it is first of all based upon gas. So whenever gases combine, whenever the gases would combine, they do so in a simple, they do so in a simple ratio by volume. We are going to see here what is this simple ratio by volume. What does this mean? Okay, so they do so in a simple ratio by volume, provided there is provided there is constant temperature and pressure conditions. Okay, constant, or you can say same temperature and pressure conditions need to be there. Let us see what does it say. Whenever the gases they combine with each other, they always do so in a simple ratio by volume. What does this mean? I'm going to give an example. Say I have N2 gas. Okay, I have N2 gas. Okay, when I combine this with H2, okay, H2 which is also gas. Okay, we get 2NH3. We get 2NH3. Okay, which is also a gas here. We are dealing with gases right now. So if you see here, N2 gas, so you have to write here 3H2 in order to balance this. So that's why you're going to get 2NH3. Okay, so 2N2 gas, 3H2 will give you 2NH3. So here it is what? This is one volume. Here this is three volume. And here it is two volume. So if I say how are they combining? So they are combining in this beautiful ratio of 1:3:2. Okay, so the ratio is going to be 1:3:2. So this is how they combine. And this is what we mean by the statement simple ratio by volume. Okay, because we have seen this, this is the ratio by volume. Ratio by volume. Okay, I hope it was clear. Okay, now let us come to our final law, that is Avogadro's law. Avogadro law. So when I talk about Avogadro's law, you all know what is Avogadro's number. This is 6.022 into 10 raised to the power 23. Okay, so this is how much atoms are present in 1 mole of a compound. Atoms in 1 mole of a compound. Okay, what does this what does the law state? So there is a scientist by the name of Avogadro. It is the name of the scientist upon whom this law has been named. It stated, basically Avogadro, he stated that the atoms cannot exist independently and hence they always exist as molecules. ठीक है देखो, if there are atoms, so they are not capable of independent existence in any case. Okay, you have never seen like H, or you have never seen like N. It is always H2, it is always N2, right? So they cannot exist independently. Independent existence is not possible. So in order to exist, what do they do is that they form molecules. They combine and form molecules. Okay, so they form a molecule, right? So I hope that this much was clear to you, and I hope that you understood all the concepts. If you are unable to understand anything, you can of course rewind the video and watch it again from the part where you found some kind of, you know, issue with the understanding part. And if still you are not able to understand, so you can write in the comment section below, okay? And I will try to answer it in the next video, okay? So thank you so much, guys. And if you like the video, please subscribe to the channel and do leave a like so that I know that you guys like the content and I make more of it. Okay, so thank you so much. Have a very nice day. Bye.